Hello and welcome to Layer Zero, where we create videos that break down complex topics into mathematical foundation and intuitive understanding. And welcome to our series Demystifying AI from the Basics, where we talk about what AI is all about and how they apply to us, whether we use them to excel at work, keep up with school, or for any other reasons. I will demystify and break down AI concepts so that you too are knowledgeable to understand the transformation that is happening now. In our last video, we saw the history of AI and looked into what AI is all about. And in this video, we will learn what is machine learning, what is this term MLOps is all about, and the different types of machine learning. So let's start. What is machine learning? At its core, machine learning or ML is a subfield of artificial intelligence and computer science that focuses on building systems that learn from data, identify complex patterns, and make highly accurate decisions with minimal human intervention. Now, this is different from programming because in programming, humans must completely understand the logic of a problem to solve it. A software engineer writes explicit rules like if and then statements and feed them into a computer along with data to get an output. Now here's where it fails. It fails on complex, chaotic or subjective tasks. For example, writing explicit rules to identify a human face in a photo is nearly impossible. You would have to code rules for every lighting condition, angle, skin tone, facial expression, and shadow. The code would require billions of lines and still fail. But in machine learning, this reverses it. Instead of giving the computer the rules, we give computer the data and the desired outcomes. The computer uses advanced statistical and mathematical algorithms to calculate the hidden connection and the rules itself. So the solution to our previous problem is to build a facial recognition system with machine learning. You feed an algorithm millions of faces and the computer mathematically calculates what features, distance between the eyes, nose shapes, edge contrast, reliably constitute a face. The resulting rulebook it creates is called a trained model. Now, the ultimate goal of AI, or in this case machine learning, is a critical distinction in the definition of machine learning is the concept of generalization. The goal of machine learning is not to memorize the data that it has already seen, and that's just the basic data storage. The true power of a machine learning model is its ability to take the mathematical patterns it learned from the past data and successfully apply them to a completely new and unseen data. Let's look into machine learning operations, or in short, MLOps. Now, to understand this picture, you have to not look at its code, but it is an automated supply chain for intelligence. In a production environment, this entire loop runs automatically using code pipelines, CI/CD for machine learning or MLOps. So let's do a breakdown of this. First comes data ingestion. Data changes consistently, and if a model was trained on January's data, it might fail on June's data. So versioning data treats like a source model. Data validation. This prevents the garbage in, garbage out, ensuring that the incoming data matches expected formats, ranges, and types. Data pre-processing. Raw data is messy and unreliable to computers. This stage transforms text, images, or chaotic numbers into clean mathematical vectors. Model training and tuning. As shown by the up and down arrows, this is an intensive trial and error cycle. Training finds the parameters or internal weights, while tuning adjusts the hyperparameters, the settings dictating how the model learns. Model analysis. High overall accuracy can hide dangerous flaws. A model might be 95% accurate globally, but 0% accurate for critical minority group. Model validation. This is like the final exam. The model is tested against a strict holdout dataset it has never interacted with before. And at last, you have one of the model deployment. This packages the final mathematical model and hosts it as a live, highly available service. To make sure it is adjusted to the real world changes, model feedback loop is there. Because the real world model changes, causing models to decay, a phenomenon called model drift or data drift. For example, a fraud detection model built before a global shift in consumer behavior will quickly become obsolete. As a result, this entire life cycle continues as long as we have a good model for reaching our goals. And this particular life cycle is not for one type of machine learning. It's instead having for different types of machine learning. So let's look into the types of machine learning. So in this, we have 5 primary paradigms of machine learning categorized by how they handle data and guide the learning process. First, we have supervised learning. Here we have the model that learns using labeled data and every input comes with a matching correct answer. Unsupervised learning. The model learns using completely unlabeled data. The answers are not provided in this situation. Reinforcement learning. The model learns through trial, error, interaction, and feedback. Semi-supervised learning. The model uses a tiny amount of labeled data combined with a massive amount of unlabeled data. Self-supervised learning. The model automatically generates its own labels directly from the raw unlabeled data. So let's look into the examples on these types of machine learning. First, we have supervised machine learning, which is a spam filter. So a spam filter is used by Gmail or Microsoft Outlook. And in supervised machine learning is like learning with a teacher. The algorithm is trained on a dataset where every single piece of data is already been explicitly labeled with the correct answer, spam or not spam by the humans. So this is how it works in this case. In the labeled dataset, before the spam filter can protect your inbox, the Google or Microsoft engineers feed the algorithm millions of historical emails that are already accurately tagged. So if one email says, "Hey, are we having the meeting at 1 p.m.?" it is labeled as not spam. But if there's another email says, "Congratulations, click here to claim your free $1,000 gift card now," it is labeled as spam. Next, we look into feature extraction. The algorithm scans these labeled emails to find mathematical patterns and features that separate the good emails from the bad ones. It looks at keywords, high frequency of words like wire, money, lottery, or act now. Metadata, the sender's IP address, missing domain verification, or an unrecognized email header. And last, formatting, all caps, subject lines, and excessive exclamation marks or hidden tracking links. And after getting this feature extraction, next is training the model. The model looks at the labeled email, makes a guess, and compares its guess to the actual human label. If it says second email and guesses not spam, such as for "Congratulations, you won a prize," the system corrects it, saying, "Wrong, the label says spam, adjust your mathematical weights." It repeats this feedback loop millions of times until it can accurately predict the label of any historical mail. Now let's look at what happens after it's deployed in the production or real-time prediction. Once the model is highly accurate, it is deployed to your live inbox. When a brand new email arrives from a stranger, the email has no label yet. The supervised model analyzes its features based on its past training. And then it calculates a probability score. For instance, there is a 98% chance that it is a spam. If the score crosses a certain threshold, the email bypasses your primary inbox and lands directly in your spam folder. Now there is a human feedback loop in this. Supervised learning requires constant updating. Every time you open your spam folder and click report not spam, or find a junk email in your inbox and click mark as spam. You are personally creating a new labeled data point. The engineers feed your conversations back into the model so the teacher can make the algorithm even smarter for the next day. Now let's look at the other example, which is unsupervised machine learning for Spotify. In unsupervised learning, there are no labels, no scores, or no correct answers. The AI is given raw data and left completely on its own to find hidden patterns, similarities, and structures. And this is exactly how Spotify uses it to recommend music you have never heard before. Spotify doesn't hire millions of humans to tag songs with labels like songs for people who like indie pop and drinking iced coffee on a Tuesday. Instead, they feed the algorithm two massive unlabeled data sources. First is the audio, the raw waveforms, tempos, key signatures, and the loudness of millions of musics. Second, the user playlist, the millions of user-created playlists on Spotify like Chill Vibes or Gym Mix or Road Trip. Next comes finding patterns. The unsupervised algorithm uses a technique called clustering. It looks at the mathematical features of data points and groups similar ones together in a giant multi-dimensional space. Collaborative filtering, that is user clustering. The algorithm looks at millions of playlists and notices a pattern. Playlist A has songs XYZ and playlist B has songs XYW. The algorithm clusters these two users together because their tastes share a hidden structure. It thinks these two users belong in the same group. The second part is content-based clustering or audio analysis. The AI analyzes the raw audio tracks. It clusters an indie song by a brand new artist text to an established song by the Black Keys. Because their guitar frequencies, their acousticness, and their beats per minute match mathematically, even if no human has ever compared them before. Because the model clustered you into a group with similar music fans, it looks for gaps. If user B loves songs X, Y, and W, and you love songs X and Y, the unsupervised model realizes that song W is missing from your cluster. On Monday morning, Spotify drops song W into your Discover Weekly playlist. You listen it, love it, and wonder how Spotify read your mind. It didn't. It just grouped you into a mathematical cluster. Now let's look at another example, which is reinforcement learning from Tesla's full self-driving beta. Unlike standard AI that learns from static data, reinforcement learning learns from an agent through trial and error by interacting with a dynamic environment to maximize a reward. So here's how it works. There is an agent, that is the car's onboard computer software, and the environment, the real world, roads, traffic lights, pedestrians, weather, and other cars. Then we come to the action and state. The state is what a car perceives at exact millisecond. For example, I'm at the left lane going at 45 miles per hour and a car is 20 feet ahead is braking. The action, the choices the car can make: steer left, steer right, accelerate, brake, or stay constant. And then comes the reward system. Developers write a reward function, a point system that gives positive points for good driving and negative points or penalties for bad driving. So for positive rewards is like for staying safely in the center of the lane, maintaining a smooth ride, reaching the destination faster, stopping smoothly at red lights. Negative penalties is hitting a curb, braking too hard, drifting out of the lane, or causing a collision. Now here comes the trial and error loop. Because putting an untrained AI on real roads is dangerous, the car does millions of miles of trial and error in a hyper-realistic virtual simulation first. The AI drives randomly at first, crashing constantly and receiving massive negative penalties. Over millions of simulated hours, it learns. When the state shows a red light, taking the action brake gives me a high reward, while accelerate gives me a massive penalty. Once the AI consistently hits high scores in the simulator, the software is deployed onto the physical cars on real roads. In our third case, which is semi-supervised learning, is for Apple Face ID. Apple Face ID uses a similar semi-supervised concept to adapt to your changing face over time. When you first set up Face ID, you rotate your head in a circle, and this creates your initial highly precise labeled dataset. The unlabeled stream. Every single day you unlock your phone thousands of times in different lighting, whether you wear makeup, you grow a beard or wear glasses. These daily scans are unlabeled data. When the Face ID successfully unlocks your phone, even if you look a bit different, the system takes a new unlabeled scan, converts it into a pseudo label of your face, and uses it to update its mathematical model. This is why Face ID doesn't stop working when you grow a beard, or it constantly learns from its own successful, unpredictable, unlabeled predictions. Last, we are talking about self-supervised learning, which is ChatGPT. In self-supervised learning, the AI creates its own labels from unlabeled data. Instead of humans labeling the data, the algorithm hides a part of the data from itself and tries to predict the missing piece. So here's how it works. To build a language model like GPT-4, OpenAI downloads massive portions of the public internet, Wikipedia, books, news articles, and Reddit threads. This is billions of lines of raw text. No humans are hired to label this text. Then the algorithm automatically turns this raw text into a game of hide and seek. It takes a normal sentence and hides the words to test itself. For instance, if the word is, "the quick brown fox jumps over the lazy dog," what the AI sees is, "the quick brown mask jumps over the lazy dog mask." The AI automatically knows the correct answer is fox and quickly because it is the original sentence. The model guesses the word and it guesses fox and quickly, and it corrects itself. If it is wrong, it corrects itself, and it repeats this fill in the blanks loop trillions of times across the entire internet. By trying to predict the next word over and over again, the AI learns grammars, facts, reasoning, and human culture. It figures out that the chef cooked a dash is likely meal or steak, but definitely not a spaceship. Once this self-supervising training is done, the AI has a deep understanding of language and it is ready to power a chatbot like ChatGPT. So let's recap. We have seen what machine learning is all about. It means it's learning from the data, learning the complex patterns, and not just programming. We've seen what MLOps is all about, machine learning operations, how a model is trained from the data and how it is deployed and how it is monitored. We have also seen the different types of machine learning and their examples. We have seen supervised learning, unsupervised learning, reinforcement learning, semi-supervised learning, and self-supervised learning. And before we end this video, I wanted to ask you a question. Can you think of an app or a tool that uses daily and is secretly powered by one of these ML types? Which type do you think it's using? And when you answer this question, you will be surprised with its answer. And now we have learned into what machine learning is all about. We have seen how they apply to the real world. And in the next video, we will deep dive and demystify deep learning and its applications. So see you all in the next video.